Hi, it's Gadget UK here again. Hopefully this will be the final part of this PC Engine repair here. Interesting thing, I've removed the 6260 and I've got a load of corrections to make here about things that I can clarify now, things that I've learnt along the way here. Did I say 60? The 6270 is the GPU, the 6280 is the CPU, the 6260 is the DAC, amongst other things. I don't think it's just the video DAC. I think there's probably some other stuff going on there. And the sound's built into the CPU. So that's pretty crystal clear now, and I can show you the service manual, some pages from the service manual in a minute, just to help you understand the architecture and stuff there. I think I've got like a block diagram or something, just an overview there. If I'd looked at that at the start, it would have made things a little bit clearer, but in any case, we did identify this is the problem. That was the problem all along. That's what was causing, that's what causing games to not work. And then when I replaced it, we had two stuck bits. I think it was pin 75 and 74 or 75 76, the upper address bits onto the VRAMs here, stuck in predominantly a low state. I did see some activity on one of them, but not much. But that might have been correct. I don't know. I was focusing on pins at the 75 here, I think, and that would seem to be stuck low pretty much all the time. So I've got the replacement chips. We'll open those in a minute. I'll show you that. What else was I going to say? Yeah, so the video DAC, the one that they sent me last time, it seemed to work okay, but it was a bit noisy. There was some like pixels and things, not really pixels, but like noise over the display. So I'm not sure that one was particularly good. DAC that they sent me, but out of interest, I thought we'll test this without this, because in theory it should do the same thing. And if I switch this on, you can hear we get the music for Space Harrier there without the GPU. You get a different thing going on here with the display, which is interesting in its own right, because that shows reliance there on the GPU in terms of the DAC. There's a bus, some sort of bus. I think there's a bus. There's probably at least an 8-bit bus between the two here, in order that this can generate, an analog output based on the digital GPU output, if you like. It might be directly or indirectly addressing the VRAM in order to work out what to display, or it might get spoon-fed by the GPU itself. I'm not really sure how that would work. But it is interesting. Like I say, I switch that off and on. You can hear the music. So the one thing we have learned through this series of videos here is it's worth getting yourself a copy of Space Harrier, because that's a good test. You start getting black screens and weird display problems and things on these, and it's just doesn't seem to be working at all. If you get the music on Space Harrier, your sound's okay. Well, might not, all the channels might not be okay, etc. But in general, the sound is okay, and the CPU is probably okay. Now, you might have problems with the DMA there. There might be some problems with certain address bits and things, some of the upper address bits. I'm not sure, but it's certainly a good test. It could certainly, if you get the behaviour I have, where you get the music here and then nothing else, it would suggest that the 6270 here, 6270. So anyway, we'll get the new 6270 on there now and see whether it works or not. So I've got my ESD wrist strap on here. We'll open this up. I'm just paranoid about this. I've just got the feeling it's going to be a similar thing where these chips just do not work. But hopefully we'll be proven wrong. So let's just make that out of the way. Interesting, let's put it in a box this time. See if we can open this. It's really weird how you would send 2 chips just in a jiffy bag and 3 in a box, and then inside a jiffy bag. Oh, there you go. Bubble wrap again. Not ESD safe. Let's see what we've got. 6270. 6270. I hope it's not just removing faulty chips and trying to sell them, because that would really annoy me. 6280. And I will be testing all of these, actually. I'm going to go as far as to put one on, test it. Hopefully it might work, and then we'll take the 6270 off. 60 off, sorry. Yeah, 70 off, and then put the other 70 on, test that one, and then we'll remove the CPU and change that as well, because I just wanted to see what level of confidence we can have in this guy as a supplier. So let's get the board here now. I'm not going to bore you with the soldering process here, but we'll just get that in place and solder it on. Well, it was really easy to put that on. That's taken about a minute, so we'll go power it up now. Let's just let it cool down a sec. It's still a little bit warm. Just give it another minute to cool down, and then we'll go test it. So the moment of truth here, is this going to work? Power on. Well, what do you know? Give me a decent working chip and actually things work alright. All signs are that's looking very positive. Let me switch it off. I'm just going to get the controller up and we'll try with the controller. So controller connected here now. Let's see what happens. Start. Yeah, I would say that's working actually. Oh yes, very pleased. Let's just try a different game. Let's get Operation Wolf and R-Type in there. So I've got Operation Wolf in there. Let's try that. Oh yes, that's looking alright. Yeah, I think we'll call that a success. As I say, I'll probably remove that chip. It's a bit risky, but I'll remove it and I'll put the other one on there, and we'll do the CPU as well after I've done that one, just to give me some confidence. But yeah, could have just been unlucky with that first chip they sent me. It could also be, this is me being cynical, it could also be that the fact that I pointed out, what was wrong with it. I told them there's 2 specific address lines stuck, and I'd, obviously used sufficient ESD protection. It may well have made them think, oh, damn, we're not going to be able to scam this guy because he seems to know what he's talking about. But that's just me being cynical. I trust nobody, and that's the way you've got to be, I guess, these days. Really. But yeah, I think that's a success. I don't see any problems there. Let's just get R-Type on there. So R-Type connected now. Let's switch it on. And the interesting thing is this one gives a white screen when you power it up, and I think that's quite normal from what I've read. But my other one, my working one, gives a lime screen, lime green. So I'm not really sure what's going on there actually. Could just be a revision difference between GPUs or something, or DACs. More inclined to think it's going to be the DAC. I did wonder at one point whether it was indicative of a fault, depending on the colour you get. But I don't think so. I don't think there's any BIOS or anything on these. So unless there was something built into the GPU or something, or CPU, I don't know how that would work. Yeah, I would say that's working. Oh shit. Let's get another game in there. So I've got Populous in here now. Let's check that out. Yeah, that seems working alright. I hit the wrong button there actually. Yeah, that's working sweet. So working 6270 off, and we'll get the next 6270 on. So I've got the other 627 on there now, let's give that a try. So it would appear that that one works as well. So I've got some good replacements there. I might not remove the CPU, I'm not sure. I think I might just trust that it works. So with the controller connected now, let's just see if that works. Yeah, sprites are looking alright. So, end of the journey here on this PC Engine. I'll show you up close here. You can see the solder points, they're pretty good really. I think after that's age, you wouldn't be able to tell. I'll probably replace those chips, those two. So, I guess what I've learned from this, well, there's a few things, I could have done this cheaper by just buying another PC Engine, because these things are only 30 or 40 quid. Bearing in mind this one I think was 30 second hand with a a fault, but 40 or 50 for good condition working ones is typically what you'll pay. The chips worked out $13 each plus shipping, so I've got a spare with a 6260 with a bit of noise on it, and then I've got another 6270 that works, and I've got a 6280 that I think probably works. I'll just trust it. I can't be bothered swapping the CPU as well. It's not worth it, but I've certainly proven that the original fault was the 6270 here, the GPU, and also learned that if you use Space Harrier, it's a good test, because one of the first things that game does is initialize the sound. So if you've got a GPU problem, problem with your 6270, or a problem with your 6260, the sound should work in Space Harrier if the CPU's okay and you've got access to your WRAM. So that's a good test really, and I would surmise that from that if you got a system where it was black screening and you put Space Harrier in and you didn't get any music at all, I would start to look at the work RAM and the CPU, and then if you are getting music, let's say in a black screen, you probably just no video at all, you're looking at 6270. If you've got graphical problems, start by checking your RAM, but if you've got stuck address lines, perhaps compare like I did to a working system, just to make sure that the address lines that you're looking at that appear to be stuck are actually utilised in that particular game. They probably all are between different games. I'd be amazed if there's a game that's not using some of the upper address bits there. There might be. Some of the early titles might not use all of the VRAM, but no, I doubt it. I think they're only 64K these. It's going to be using all the VRAM pretty much in every scenario. So if you get any stuck address bits, yeah, you're looking at a faulty 6270. And then for sort of video problems in general, you've got your DAC here, so you could get problems with that. If colours and things are not right, yeah, I'd suspect the DAC. But like graphical corruptions, you're more likely in the realms of the 6270. Sorry. So it's all up and running here. It's been running for a good half an hour actually on test. No problems at all. It's looking pretty clean. I'll show you on the underside of the board in a minute so you can see some of the components. And I guess I'll just turn this down a sec. It's probably worth mentioning some of the other things that I've done and noticed and learned about this as I've been going along. The first thing is, since I've changed the power supply, sorry, you can't quite see that, can you? Since I changed the power supply to use a 9-volt power supply that is outputting actually 9 volts DC, this heatsink is a lot cooler, and the system as a whole runs a lot cooler, and it's the same with my other PC Engine. So other things worth pointing out, I'll switch it off, I'll just show you down the side here. There's a diode there, and I believe that's for reverse polarity protection, and it works in conjunction with a fuse. So if you were to put polarity in the wrong way, that diode will feed whatever input you've put straight to ground, which will cause a massive surge in current below the fuse. So not sure if that's what's happened. I suspect the fuse, as you can just about see, can you see that blob of solder? Looks like someone's replaced the fuse previously. So I think maybe the fuse has gone for another reason, probably from the original GPU faults. There's probably a spike, at the point where a transistor went or something in there at that point when it failed. And that probably took out the fuse, I think. It could also be that it failed and then someone passed it on, somebody else stuck a power supply the wrong way around, blew the fuse, passed it on to somebody else, etc. But I thought that was worth pointing out as well. There's the cap that I replaced here, close vicinity to the heatsink. Yeah, that was leaky. All the others were okay. So I think they're mostly 1 microfarad. There's a couple of 47s or something on there, or 22s I think. But for the most part, the caps on these are very reliable. It's this type of cap you seldom need to replace. So if you get one of these that's faulty, I wouldn't just go in and assume that you need to recap it from the off. Perhaps just do check 1 or 2 of the ones near the heatsink here. But the others are just, they're going to be alright. These are going to be alright for decades to come, I'm sure. Long after I'm dead and buried, these things will still be working, I'm sure. So just a quick look on the underside of the board here, because I don't think I've shown it. Obviously you get one of these and you can see, I talked about this actually when I tore this down initially. Someone had removed this, you know, you could see there's a bit of messy solder here, and on the other side the piece of plastic had snapped off. It's, yeah, it should be alright, so I'll clean up the solder points there and resolder that back on. But as you can see, the underside of the board is in very good condition really. You perhaps can't tell where I've taken all these caps off and checked them all. But yeah, there's loads of little SMD resistors. That's like, I think, a block of pull-ups. I think they're all 4K7s. There's loads of 4K7s at various places. I think there's a big block there, you can just about see. 3 transistors, I think those are the ones that show up in the schematics there, probably for the video outputs. Not much else really, some SMD caps, very little else. I think this has been reflowed by somebody else previously. One of the first things I noticed, that someone must have just decided to just reflow it to see if it was something to do with the connectivity there, but no, it's not that. I might just clean that up actually while I'm there. But yeah, so not much more to show you really. I think I'll put the, perhaps clean up that the solder points and there, put this back on and reassemble it. So I thought it'd be worth just showing you some of the diagrams and things here now. So if you have a look at this block diagram, this is from the TurboGrafx 16 service manual, and obviously the chipset's going to be the same. It's going to have the main 3 chips. Now early on I made some total cock-ups on the first few videos in terms of referring to certain components you know, incorrectly, talking about the GPU and saying it was a CPU and saying that the 6280 was an audio chip and I/O, blah blah blah. Yeah, lots of mistakes there. Part of the reason for that is there's a lot of misinformation out there on forums and things. You know, you start searching for some of the symptoms and things you know you get when you got a fault, and people start jumping in and saying, oh, it's your CPU, swap out your 6270. That's not the CPU, that's the GPU. And then you get other people saying, oh, it's your sound chip, the 6280, and that handles I/O as well. That's sort of true, it does handle sound, and I think it handles I/O from what I've seen, but actually it's, in fact I think some of the I/O might go through here. The 6280 is your CPU, your 6260 is a video DAC, so you know, digital to analog conversion there, and it should be obvious, you know, if you look at these, there is a bus here, you know, when I pointed out in a previous video actually, there's a bus between the 6270, your GPU, and your 6260, your DAC. So this is how your DAC is generating the video output. I guess and that would make sense perhaps from the VD, must be video data bus. I think the video's pushed out to the 6260, it might pull it, I don't know, via some sort of request. So that's how that works, and as you can see, you know, the thing that reinforces the fact that the 6270 is the GPU, as I suspected towards the back end of that last video, you've got your VRAM here, and you can see you've got the address bus and the data bus coming through these connections here, straight, you know, through to the MD and MA buses on the 6270, and there's nothing else connects to those. I hope that's clear. And then if you look at the expansion connector here on the back, you've got your backbone of your system, your A0 to A20 address bus and your data bus 8-bit, and those sort of go to all of the components. So your Hue card is connected to your address and your data bus, which is interesting, and that's one of the reasons why I like, you know, you've got this switch here and it engages on the front to lock your card in. Without something like that, you could remove the card and stick it in while it's powered up, and that sort of thing can actually kill some of the components on here. You know, you get a spike on your address bus or your data bus. It's a similar thing with the SNES. Someone asked me recently about how the region adapters on the SNES can cause the system to fail, and it's not really the region adapter as such, it's use of the region adapter on the SNES, because you can just plug them in. You know, you can plug carts into the SNES whilst it's powered. You know, there's nothing to stop you doing that, and you can even get the carts in the wrong way on the SNES. So things like this mechanical protection mechanism here are invaluable really, in terms of protecting the backbone of the system, the bus, the address bus and the data bus. So what else have you got? The audio amplifier here, you can see, is connected up to the audio output of the CPU. So the CPU does provide audio output, and that is reinforced by an article I read yesterday actually that suggests that if you try and overclock one of these systems, your audio increases in frequency, which makes sense because it's embedded within the CPU. It's tied. It's a bit like it is in the NES. Think of the NES with the PAPU. It's a similar thing. Your audio circuitry seems to be on board the CPU die there. And again, coming back to the backbone of the system, the address and data bus here, you can see you've got your card, you've got your 6270, connections there. You've got your work RAM, so everything on the bus has got access to your work RAM, which is interesting. And your 6260 video DAC also has access to your work RAM as well. I'm not sure why it would need it, but yeah, certainly from this diagram it looks like that's the way it's wired, and obviously your CPU's got access to the full address and data bus as well, your full A0 to A20 range there. So yeah, it's quite simple really when you look at that diagram, and like I say, this does apply to all of the PC Engine models really, probably with the exception of the Super version. I forgot what it's called now, the Super PC Engine or whatever it is, the one that's got, I think it's got two 6270s, hasn't it, but a single CPU. So yeah, I might have a chance to look at one of those one day, but they're quite expensive and there's only about 5 or 6 games work on that system. But if we look at some of the other diagrams here now, I'll post some links to this service manual so you can have a look yourself at your leisure. But if you look here, the 6280, this is the CPU. I'll try and zoom a little bit just so you can have a closer look. So the first thing I noticed when I looked at this is, you've got the work RAM here. So on first inspection, you could just assume that the CPU is the only thing that's got access to the work RAM. But as I say, come back to this block diagram, and you've got these, the backbone of the system seems to, everything seems to be able to connect to the work RAM there. So let's just move that across. And then the other interesting thing here, I think this is inputs. You can see protected by these little inductors and caps. Yeah, DI0123 cell clear. So I think those are your control inputs by the looks of things. So the CPU handles I/O, well not output, but input. There might be some output somewhere, but yeah, certainly input is handled by the CPU. So if you get a problem where controls are not working, buttons not working, and you've checked all of the components here, you checked all the components here, you've checked your connector, you're getting a connection through to the relevant pins on the CPU here, you've got a faulty CPU. And it's a similar thing with sound. If you've got sound problems, certain channels missing, etc., you'll notice all you've got there is L out and R out. So a sound problem is going to be integral to the CPU. Not 100% of the time. You might find you've got a RAM problem or something, and that it's trying to play sound, load samples, play some of the music from certain addresses, and that's messed up because the addressing of the CPU is not right, or not necessarily the CPU, but the actual work RAM. If you've got problems with the work RAM, I suspect you could have sound problems, amongst other things. Generally, the system won't boot if you've got problems with work RAM, but if you had problems with certain addresses and things like that, it was a bit flaky. There, sound could certainly be either the work RAM or the CPU. And if your work RAM was dead, I think your system probably wouldn't boot. There might be a few exceptions to that. Maybe Space Harrier or one or two of the games might start playing sound without use of that work RAM. It may well just point the audio section of the CPU to an address in the car, and it may well be playing music from the car. So there's a few things there to think about as well. I honestly don't know. It's one of those things that I'd need to spend hours and hours really connecting a logic analyzer up to try and follow through and see exactly how the different carts work and stuff. It's the intrinsics of the system again. I'm not familiar with how some of the games work. I guess in terms of, if you wanted to learn more about something like that, probably a good place to start actually is looking at emulator source code, because you can learn an awful lot about the internals of these systems and how they work just from looking at the emulator source code. In terms of, if you look at find the part of the code where it loads the ROM, where the ROM gets loaded into, what then happens sequentially, you can learn quite a bit about various systems. That was one of the things I did with the NES when I wrote an emulator for the NES. It was quite useful really. I learned more about the NES than I perhaps know about any other system for that reason. So that's that page. Let's have a quick look at this one. This is the video DAC 6260 here, and as I showed on the previous video, you've got some transistors here to do with the RF output and stuff, but you've also got these connections up here. Video R, video G, video B, sync, comp video. So you've got 5 video outputs there, your analog video outputs, and then you've got this data bus I showed a few minutes ago, this VD data bus that connects to your GPU. That's all those connections there. Some interesting stuff going on here. It's like some biasing or something. I'm not sure what the hell this is all about. Comment below if you got any clues, but you can see you've got like RGB plus, RGB minus, SYN plus, SYN minus, Y minus, Y plus, RY plus, RY minus, all the way up here, BRT minus, BRT plus. Is that brightness perhaps? Y, is that colour? So, and then all you've got is, you know, connection to ground and some caps. So I think we've got some biasing type stuff or something. I don't know, I'm not that familiar, I'm not that hot at the theory side of electronics. It's a long time since I did anything, and I was only really in the industry for 3 or 4 years, so and it was many years ago. So looking at the last page here, we've got the 6270, your GPU. You can see there where I circled those 2 pins, 75 and 76 on the last video. So yeah, that was the clue, and that was ultimately the solution, that on that particular chip, 75, you know, pin 75 and 76 were stuck below those 2 upper address bits. And you can see they just connect to the VRAM here, and there's no other connectivity on the address bus to the VRAM, as we've seen on the block diagram there. Your data bus just comes off and goes back through to the GPU, so there's no other reliance on anything else or anything that could have been dragging those low, which is what, you know, I knew that when I'd looked at the diagram and seen the block diagram. It was pretty conclusive to me that that was the fault. It's just interesting. I guess we've learned something else from that, in that you know, the GPU they gave me had a different fault. It had these 2 stuck address bits. So if you get problems with graphical corruption, yeah, your first bet, as I say, is probably your VRAM. But then beyond that, you're looking at a faulty GPU, you know, the 6270. So what other connections you got on here? You got some V-Sync and H-Sync lines that probably go elsewhere in the system, that might even connect to the DAC. So you can just about see come down here. I think that's pretty much it, really. There's not much more else to show you, I don't think. That's just one of the other pages, I think, at the end of the thing. But we've also got these, and I'll stick these, a link to these as well. I think these were from the Console 5 wiki. I'm not sure if something was mislabeled on here. I think it might have been. Yeah, I think they refer to that as the GPU, the 6260, and it's not. It's actually video DAC. 6270 is not the CPU, that's your GPU, and your 6280 is, as I say, the CPU and, you know, inputs and APU. So just before I put the lid on here, can I have a quick look at the board here? You can see both those RAM chips have been swapped out at one point. That chip has been removed and resoldered. That chip has been removed and resoldered, and that back one there's been reflowed. So yeah, I'm pretty pleased with the end result there. Like I say, after that's aged a bit, I don't think you'd know that that's been worked on. So there we go, there's the end result. It's looking almost as clean as this one. The red logo there is just not quite as vibrant as this one is, and it's got obviously a couple of little marks up there, but actually it's not bad. At least I've got a spare now. There we go, all connected. Thanks for watching, I'll see you soon.